Why can a tiny engine feel like a much bigger one without adding a single extra cylinder? The answer is hiding in the exhaust, wasted energy that a turbo turns into power. A turbocharger is basically an air pump powered by exhaust. It crams more air into the same engine size. More air lets you burn more fuel cleanly, and that's what makes more power. It's like giving your engine bigger lungs, without making the engine physically bigger. Inside the turbo are two fans on one shaft. Exhaust gas hits the turbine side first and spins it, sometimes well over 100,000 revolutions per minute. That same shaft spins the compressor on the intake side. The compressor squeezes incoming air, raising its pressure before it enters the cylinders. Engines don't really care about how much space air takes up, they care about how much air mass gets inside. Boost increases air density. Denser air means more oxygen molecules packed into each intake stroke. More oxygen means the engine can inject more fuel and still burn it properly, so torque rises everywhere the turbo is making boost. But compressing air also heats it up, and hot air is less dense and more likely to cause knock. That's why many turbo engines use an intercooler, a radiator for intake air. Cool the air down, density goes up again, combustion stays safer, and the engine can run more boost and more ignition timing without damaging itself. Here's the catch: unlimited boost would destroy the engine. So turbos are controlled. A wastegate opens to divert exhaust away from the turbine when you've hit the target boost. Modern engines also use sensors and the ECU to manage fuel, timing, and boost because pressure and heat rise fast, and reliability depends on precise control. You've probably heard of turbo lag, that pause before the turbo wakes up. At low RPM, there isn't much exhaust energy, so the turbine accelerates slower. Engineers fight this with smaller turbos, twin-scroll designs that keep exhaust pulses strong, variable geometry turbos that change flow angles, and even electric assist in some new systems. Turbo power isn't free. You're pushing more pressure into the cylinders, so parts see higher stress and higher temperatures. Turbo bearings need clean oil. Cooling matters. That's why turbo engines often have stronger pistons, better cooling, and careful warm-up and cool-down behavior. Do it right, and a small engine can be efficient and powerful. Do it wrong, and it becomes an expensive lesson. So the turbo's real magic is simple. It recycles exhaust energy to pack more oxygen into each cylinder. That turns a small engine into a big air engine on demand. Next question: why do some cars use two turbos instead of one, and when is that actually better?